You can stand up.
Alright, good afternoon everyone. My name is Judy, this is Raymond, and this is Kelvin. Today our team is going to investigate with you how the camera's eyes, that is the CCD, and call it charge coupled device. And when such light reaches the CCD, the signal will be amplified and converted into a digital format by the analog to digital converter. And after that, it will go through some more processes, and then the picture will become one that is in a digital format. And it will be stored in memory card or displayed on the screen. Like when we're visualizing, the memories or the pictures will then be stored on a frame. So the process is like just how we see things. And throughout the whole process of how a digital camera take a picture, the most important thing is the CCD. The CCD is like the eyes of camera. And so Raymond, would you please share with us your understanding on CCD?
Okay, a CCD is a two-dimensional grid of semiconductor capacitor that can transfer the electronic charge between each other. So CCD itself is a strip only, and the imaging system, that is the camera, we call it a CCD camera. Initially, this CCD is designed as a memory device, just like your hard disk, your USB, but due to its properties of high sensitivity of light, as it converts light photons to electrons with extremely high efficiency, that is 100 times around this number, and greater than the frame, traditional frame. So people use it as the eyes of the CCD camera. So when light comes in through the lens and into the digital camera, the light photons will create some small charges each time they strike the capacitor, the CCD. And more photons striking, more charges build up. So you can see this arrow. The light flow is more brighter, and so it will create more charge on the CCD. So there's a darker color, shows more electric charge. So this large square is the CCD, and each small square is the pixel. So each pixel contains, when light comes in, each pixel will contain different amounts of charges, and they will transfer volt by volt to the serial register. And each information of the charges will pass through one by one through the terminal and amplifier and convert that and get into the ADC. And the ADC will convert all the charge information into digital form. So practically, the CCD records only the light intensity, that is the distribution of the electrons. So practically, this is the CCD can only create a black and white picture. So how do a CCD camera make a color picture? So Kevin will tell us now.
And now let's move on to the next one. That is the RGB color model. What is meant by RGB is the red, green, and blue light. Before we can see a colored picture form, let's study the formulation of color. Actually, different kinds of colors can be formulated through different light intensity of the combination of green, red, blue light that they can add together to form a spectrum like this. This one shown in a picture. And then it is so-called true colors are enclosed in a 24 bits per pixel. Actually, each type of color, red, green, blue, will occupy 8 bits per pixel, so come up with a 24 bits per pixel that can record the color of each pixel. And let's see here is an example. What is meant by this kind of number? They're actually referring to the light intensity of different kinds of color, red, green, and blue. So Raymond talked before that actually if we only use the CCD as the eyes for the CCD camera, we can actually see the light intensity distribution of a picture. But how can we get to a colored picture? Actually, there is a bias filter placed over the CCD. As you can see here, each square of the bias filter actually consists of one filter for red light, another filter for blue light, and then two filters for green light. Since our eye is more sensitive to green light, this is how the designer designed to capture this kind of characteristic. And it actually separates the light stream into different color streams, like when the light passes through the red filter on top of the CCD, and each such pixel will only record the light intensity of red color. And if the light is passed through the green filter, then that pixel will only record the light intensity of green color. And we can see each pixel then store information of light intensity of only one color. Before what I will explain later on about the interpolation. Actually, as we can see here, if we only consider the effects before the interpolation, we can only see three different images that consist of only red color, green in color, and blue in color. So how do a pixel actually know that in that exact position what the other two color light intensity? That means if we only consider a pixel that is light below green filter, how do that CCD capture the information of the other two lights?